Well, Brian, we're rolling a Camaro. Unfortunately, it's a 6-cylinder, but that's okay. It's my daughter's car. I can live with that. Cool. But we got to check engine light on, and you know it's rolling perfect. It's driving great.
I knew you couldn't take me to lunch without some kind of an agenda. I'll tell you what, if it's not a flashing check engine light, that's probably good, but it's definitely something we need to dig into.
Yeah, you know, I'll get it up to Tech Garage. First thing we need to do is scan it and get the code. Welcome to Tech Garage, presented by RockAuto.com. Well, we got our 2015 Camaro in the shop, and we have a check engine light. Brian, as far as diagnostics are concerned, well, man, I got nothing. It's running great, it's driving great. I don't think there's anything wrong with it, but I got that check engine light.
Pretty rare for you, because usually it's smoking, banging, rattling, something obvious is going on, but that check engine light is usually a good place to start.
Yeah, and it's a PO 128. I got our handy dandy tool under there, scanned it, no problem. We got two options at this point. Here's your electrical tape. You can tape up the light.
It does work nicely over a check engine light, but I'd rather fix the problem.
Yeah, Tech Garage, that's exactly what we're going to do. So we need to figure out what is that code, PO 128. Well, it's excessive time to get to temperature. Kind of weird. Look at this graphic right here. It actually explains what the computer does, and it's going to look at the ambient temperature. Brian, what's the ambient temperature now?
Here in the room and at the top of the radiator, it's about 68 degrees, which would be what the intake air temperature sensor is reading as well.
Exactly. The car's been sitting, so it's sucking in about 68 degrees air temperature. That's great. Well, the computer looks at that, and then all of a sudden he looks at the engine coolant temperature. Well, that's going to go up every time we crank it. Day 1, day 2, it's going up. Day 3, well, what about 6 months? What about a year? What about 2 years? And it doesn't quite get to where it used to be because it knows time. It knows where it was before. Bam, check engine light. There's our excessive time to temperature. Now, that could be as simple as the coolant fan staying on.
Could be, or it could be an open thermostat. That's a common problem where the coolant just continues to pass but never really heats up.
Yeah, it's kind of weird. It's staying too cold, all right?
Yeah.
Well, one thing we have to also check is our engine coolant temperature sensor, because he's the biggest player. I mean, that's what's going on, and I think a diagnostic check's in order. We hooked up our fancy-dancy scan tool just so you can see actually what the temperature is when it's plugged in. And what is it showing right now?
Yeah, we got 79 degrees. There's the evidence of 66 degrees here in the room, 79 degrees down at the temperature sensor. The vehicle's been off for about an hour, hour and a half, so that's cooled down. That makes a lot of sense, and again, it is a fancy way to show all this. Sure. You can do this with a gauge, I'm sure you'll show, but we're at 79 degrees right now at the sensor.
So that's about right. The car's been in here about an hour. I mean, it's exactly where it should be, or close to it. Now, so you can follow this flow chart, and you can follow along at home with us if we pull up this circuit system testing. Now, I already checked the wire resistance in the harness. It's fine, so we can do a couple things here. It says, first of all, verify with a scan tool that it's colder than 39 degrees when you unplug it. Well, that's the default, Brian. Check this out. Okay. If I unplug it,
yep.
Drops,
it's negative 40.
That's less than 39, so that's a good thing. If it didn't drop that far, well, maybe there was something going on in the wire harness or the gauge.
Yeah.
But right now, that's pretty good. So the next step, if you look down, you pull the graphic up again, it wants us to actually put a fused jumper wire between the two terminals. So I have a fused jumper wire right here, and if I take it and I go between the two terminals, go into the car, what that's going to do is bypass all the resistance. Now, when I bypass all the resistance, where did the temperature go?
302.
302. Well, our flow chart, look on the page there, it says it has to be 300, all right, or more. That's great. So we're good, 302. Now, all we did, we just verified the integrity of the wire harness all the way up, the computer, everybody's thinking right.
Yeah.
So we really need to switch over to the component test. Now, engine coolant sensors, they're big players.
They are big players. They do so much. The rich data coming from the ECT drives how much fuel gets dispensed, drives how the whole warm-up cycle, drives the vehicle getting into closed loop mode, all those things we've talked about before. It's a small guy, but it has a big job. So the component test, again, pretty easy to do right in the driveway, but that's significant. You got to do this right too.
And that's what I love about it. I mean, they're all not catastrophic codes. I mean, this chart is on the actual internet. You can find the chart. It's a resistance value according to the sensor. Now, another cool thing, if you have some wire harnesses, or I actually got this from RockAuto.com, little pigtail, I make me a little
good idea
ends to get in there because it's way down here. So I'm going to reach down here. I'm going to plug it in. And what we did is we got our meter on resistance.
Yep.
And what I'm going to do,
of resistance
yep,
here.
And I'm going to go across both these terminals, one side And then I can go on the other side here and find the terminal
You
here.
can find this information online to see exactly what your resistance in this path should be right at the component level.
Exactly, and that's huge because, you know, a lot of times these things, they just go open, but I don't believe that's the case here because it's a different code. What are you showing?
7.4 ohms of resistance.
Or 7,000. We got K,
7,000,
yeah, 7,400 ohms of resistance. Now pull up that chart. If you pull up that chart right there, we're sitting, you told us we were at about 66 degrees. If you look at the chart, anywhere from 68 to 86 degrees, we were at 3,000 to 2,000 ohms of resistance. Now look at where we're at. Look at our chart. 7,041 to 7,485 right there. It's supposed to be 41 degrees. Guess what?
Yeah, we got a bad component. We got a bad temperature sensor.
Bingo. The computer doesn't know any better. He thinks it's 41 degrees.
So it's been adjusting fuel. You've probably noticed if you'd have been paying attention and not driving so fast, you would have seen that your gas mileage probably went down leading up to this. You might have had black smoke at startup. It was definitely running rich. So fascinating. I guess my next step is grab a drain pan, and I'm going to go to the rockauto.com shelf, grab a new temperature sensor, and get this thing underway.
Absolutely. You know, stick around because when we come back from break, we're actually going to look at this sensor and a good sensor over at a table demo. We'll be right back with more Tech Garage presented by rockauto.com.
Tech Garage, presented by RockAuto.com, is brought to you by Custom Auto Sound, the originator of classic car OEM fit radios since 1977. Mobile Environmental Solutions, the leading portable mobile paint booth. And by RockAuto.com, all the parts your car will ever need.
Welcome back to Tech Garage, presented by rockauto.com. Now, Brian's hard at work taking out the engine coolant temperature sensor. How's it coming, buddy?
I got to tell you, hardly working. It couldn't be easier. A 19mm socket and the bad guy's out. This is one of those small parts that does a big job.
It really is. He's a big player. So if you put it down here, let's go ahead and hook it up just like we did before. I'm going to take the negative. I'll hook it up across it. We're in ohms of resistance, hooked up just like that.
Yep.
We can read it, and there's our 7,000.
7,700,
Yep. So it thinks it's like, whatever, 42 degrees. I mean,
Yeah.
it thinks it's cold. Now, I went to Rock Auto. I got another pigtail, and I have your actual new sensor right here. So let's go across this just to verify and let everybody see exactly what it should read. And
There you go.
There's our 3,000. If you pull up that graphic again, you look at the chart, and if you hold that graphic for a second, look at what happens when it gets hot. Resistance actually goes down. So as resistance goes down, it's a negative coefficient thermistor. Now check this out. I'm going to go ahead and torch it.
That's just like you drive.
Exactly. Let's get this thing nice and hot, like the tires.
Yep.
And see that?
Look at that.
What's happening in
Going
that
right
resistance?
down. We're leaning out the fuel mixture.
Exactly.
It's dropping.
And that's what you said earlier, Brian. You had mentioned that it's actually messing with the fuel mixture. It is, and this is a perfect illustration. Only on Tech Garage can we show you what's going on. Got that fancy scan tool hooked up. Actually got the board, and you can see right here we got the temperature. Here's the actual engine coolant temperature and the intake air temperature, and then we have the fuel injector. So you mentioned the fuel delivery is going to be determined by that temperature. Really cool. Well, fire it up and let's see what's going on. Go ahead and fire up the board up there.
Here we go.
All right, yep, there you go. Hold it. It's running now. So what we have is we have 70 degrees and we have a pulse width of injectors right here. So if you change the temperature of the board right there.
I want to get to lunch a little quicker.
There
so
you
I'm
go.
gonna crank it
2,
up.
3. Look at the pulse width's going to change. It's going to adjust. There it goes. Starts to drop down. The hotter it gets, it actually starts to take fuel away. That's pretty cool. So he is a big player. You want to cut that off?
Sure.
That's going to make all the difference in the world. You actually can see it in action there. And Brian, you better take your sensor and get started. All right.
yeah.
Now, if you look at this board right here, this is pretty cool because this is how your dash works, your dash cluster. There's nothing to it. I said it was a negative coefficient thermistor. Well, think about the rheostat in your house. You turn it back and forth. It changes and varies the actual voltage with resistance. So that's sitting right here, the engine coolant temperature sitting in the block. And if you watch the gauge up here, this is nothing more than a variable resistor. So if I change that variable resistor, it's going to go up there, vary the voltage signal, and the gauge is going to change. So it's changing the gauge as it works. So not only was the gauge probably wrong, so was the car and the fuel delivery. Now I'm going to take our vehicle speed and bump it up to about 100 miles an hour because that's what Brian's going at right now as he starts to install it.
Well, it really is almost a 100-mile-an-hour repair. Couldn't be simpler to reinstall this ECT, but before I do, this is a really good time to check the freeze point of your coolant. You can do that with an old-school hydrometer. Take a sampling, check it, make sure you're good for your climate, or you can use these strips. You can also check the pH level with some types of coolant. In this case, we've got orange Dex Cool. If you've got an import with red dye, the pH reading won't work on the strip. But before I install this, I'm going to go ahead and put the strip down in the passageway here and get a sample reading of our coolant and pull it out and compare to see for our climate if we're going to be okay. So right here, we're good somewhere between 35 and 50 degrees below zero. So we're in good shape, but you got to remember, top this system, back off when you get it all buttoned up. One final tip. You might recall our old ECT did not have a lot of sludge around the stud here, but if yours did, chances are the antifreeze didn't get changed and maintained like it should have, and that can actually skew the temperature reading ability of this sensor. So let me come down in. Take your time, don't cross-thread anything here, and be sure to follow a torque spec if you've got one. Again, we got 19 millimeter here, very simple. Get it installed. And you probably hear the dripping. We have a drain pan down there to capture all of that old coolant as it all came out. I also kept the wiring harness up out of the path of that dripping antifreeze as it went down. You don't want any of that in the wiring and the connector there. So, connector goes back on, only goes one way. Listen for the click. There you go. And be sure to reinstall the heat shield the way it was oriented. Don't forget, in this case, the exhaust manifold is really close to that sensor, and you don't want any kind of false data coming through the sensor. So, our next step is make sure we're topped off with the proper coolant. We're good on the freezing point. We can either start the vehicle and heat cycle it, check for leaks, make sure we're optimized, and then reset the check engine light before we take it on the road test, or we can go straight to the road test, reset that check engine light, and I think we're going to be in good shape, and John can quit complaining about yet another dashboard light. Tell you what, in fact, he's got his lab coat on over there. Garage Ed is next on Tech Garage, brought to you by rockauto.com.
Welcome back to Tech Garage, brought to you by rockauto.com. Now this Garage Ed segment, we're talking starters. Now what is a starter? Well, it converts electrical energy into mechanical energy to start your car. How does it do that? Well, it's all science, my friends. I knew I wore this jacket for a reason. Let's go back to science class. It's about magnetism. You can see our magnets right here. You remember like charges and then unlike charges? So what's happening? We're getting repel and we're getting repulsion. That's how a starter motor works. It's all about that left-hand law of flux, and I can show it to you right here in action as well. I got a little battery and a wire right here, and if I touch it, there's actually lines of flux going inside of there, and you see it wants to push it out. Now, if I reverse the polarity and I push it the other way, it wants to push it the other way. So it's all about that push-pull, push-pull, push-pull. Now my simple motor, if I hook it up, you'll see I got two little commutators here that's going to an armature, and it spins. Now the cool part is bidirectional motor, so if I turn this around, it spins the other way. So it's all about that push-pull. Take a look at this animation. It shows it's actually feeding into the commutator voltage, and it's spinning around. And when it spins around, you got the north and the south magnets there. And as it spins, it wants to push it out of its field of lines of flux and then draw it in and then push, pull, push, pull. That's how it works. Now it draws a lot of electricity to do that. Let's take a look inside a couple of starters. I have two of them. I have an actual permanent magnet starter and I have a field coil starter right here. And it all starts right here at the brushes. Now the brushes go right here and it feeds the power to what's called the commutator right here, and then it goes to this armature portion. Now it has a lot of little armature segments on here so it can push, pull, push, pull. Inside of our big one here, you can actually see the field coils. They get electrified. That's why it's so big, because I need the power in order to do it. I get both of them powered up and I can go ahead and start the car. How do we do that? Well, we do it with a solenoid right here. I got two terminals. You energize the battery, bam, the contacts go over, the high amps start, this guy starts to work. Now, we've come far with starters, and we're talking about permanent magnet starters now. They're a lot smaller. You can see it right here. There's actually no energization going on inside of here. It's just regular magnets, and they're fixed. Well, this guy's a lot closer, and he's a lot smaller, but he does the job. How does he do the job? Called gear reduction. That's pretty cool. So if I pull this off right here, you can actually see right there. There's a couple of planet gears. The sun gear goes right inside of here, and what we get when we spin it is gear reduction. Check this out. I got got a line right here and a line right here. And as I start to spin it, you can count them. The armature went once, twice, 3 times, 4 times. We're still not there. Almost 4.5 times around before that pinion went 1 time. That's massive gear reduction. So I don't have to use a bigger starter. I can go ahead and put it in a small case. But with that comes some problems. You know, it gets close to there, it starts to short out. We'll look at some service in the next episode when it's coming up. Got one cutaway right here. You can see everything in there. You got your field poles, you got your armature all built, you got your pinion right here, which drives out and engages your flywheel, and then you got your solenoid right there. Now, Rock Auto has an awesome selection of starters and starter components. Let's check it out with Tom. Well, Tom, we looked inside of a starter, and I know there's folks out there that have an old vehicle that maybe they just don't want to replace the whole starter with a remand or a new starter. Do you have an option on here to go ahead and rebuild that thing? People do still take them apart.
Sure, yeah, some starters are prone to the brushes wear out, or so yeah, we have the brushes, we have the bushings, have the solenoids, and then we have remanufactured starters that have been fixed. Something that's been out I don't know, it's probably the last decade now, is completely new starters for old cars. So you can start from scratch. You don't have to return a core, which is especially handy with Rock Auto. You don't have to ship a core back to us.
Right. Hey, what about this start-stop technology now? Those things are getting costly. I mean, we're dealing with Rock Auto. We're going to get huge savings. It multiplies.
Right. Yeah, you think those things have to start the car every time you come to a stoplight, and I mean the wear and tear, the bulk of the starter, the price goes way up, and you can save a lot buying those at rockauto.com.
No doubt. What's a little heart here? We got a little heart. Is that a popular solenoid, or?
Yeah, parts that customers frequently choose and infrequently return, we mark with little hearts, and that can help you as we have a huge selection of most parts. You have a choice of different brands and prices and specifications, so the heart can give you a clue what has worked on other customers' cars, what they've been happy with, and help you make your selection.
Perfect. Tom, I'll tell you what, you join me next week. We're going to do some starter diagnosing. But stick around. We got plenty more. Tech Garage presented by rockauto.com right after this break.
Tech Garage, presented by rockauto.com, is brought to you by Borla, the world's most winning exhaust. AP Laser, leading the way. And by rockauto.com, all the parts your car will ever need.
Welcome back to Tech Garage, brought to you by rockauto.com. Folks, it's time for one of our favorite segments of the show, the video question of the week.
Now, sometimes your air blows cold, but it's not blowing in the right direction. This video question is going to answer that. Check it out.
Hey guys, my AC only blowing on defrost. I mean, it's changing from hot to cold, but it's only blowing from up here. What's going on?
Josh, great question. Happens to a lot of people. Now, when it goes to defrost, that's the default mode. Now, whether it's electronic doors or vacuum doors, it's going to blow up there. So our Firebird here is actually vacuum actuated. So the first thing you'd want to check would be source vacuum. And Brian's going to crank up the car in here in a minute. I'm going to go right to it. And if I hold up the gauge, you can actually see we're pushing about 20 inches of mercury. So we have source vacuum going into the system. That's the first thing to check. That's important. Brian, that's good. Now, if you didn't have source vacuum, hey, you want to start checking it for some vacuum leaks here, and then we'll look at the temperature door.
Yeah, and the best way to do that, of course, is a smoke machine. And if you don't have one, they're not too expensive. You can even rent these in some cases. But essentially, you're going to push smoke through that entire vacuum system. Be sure you get a good viable source like this one. I saw a guy once push it up through the windshield washer nozzles. You don't want that. All right, we'll push it.
Yep.
Seen anything?
No. Eventually, if you had a leak, it would pour out, take a flashlight, starts watching it, and watch it start pouring out one of the vacuum hoses.
Give it 20, 30 seconds. I think we're good there.
Yep. You got a couple old school tricks. I mean, carburetor cleaners, watch the injection, I mean, as well.
All kinds of ways to do it. And if you got an old school pump like this, you can also do the same thing.
Yeah, and check this out. I actually have a whole control unit that's under the car. This is the gauges right here. And then on the back side, if it's old school like our Firebird, you actually have these vacuum lines right here. And the vacuum lines take the source voltage in, and when you switch your switch, it directs it to different doors. And different doors, Brian, do different things.
It's just a massive router is all it is.
That's exactly what it is. Now, watch our door here. As Brian pumps this up, our vacuum pump, it's going up.
There you go.
So bam. So when I switch to something else and I release the vacuum, boom, that's it. It's going to drop that door just that quick. Now there's different temperature doors. Now, how do we find the problem? Well, get you a little pair of needle nose pliers. You got a broken line like that, go around and pinch each one of them. I pinch it, nothing changed. That wasn't the leak. I pinch it, nothing changed. That wasn't the leak. I pinch it, bam, switches from defrost to another door. You found which line's leaking. Now that's a vacuum actuated system. Brian, electronics a lot different. We have all kinds of electronics and temperature doors.
Yeah, all kinds of ways, and all of them, many of them have a storage container like this. It's not a mailbox for squirrels. It's actually a vacuum tank where it holds a vacuum there. Everything can release, actuate as it needs to. You also want to check those for leaks. Sometime heat can crack those.
Heat, and they're usually located somewhere tucked in the fender well. I mean, a little ding or here or there, they crack very easily. So with that, hey, the vacuum actuated doors, electronically, you can plug it in, scan for codes, Josh. Once you get a code in there, it'll give you a direction on what door to go to.
Speaking of codes, it's cleared on the Camaro. I hope that thing's running well. I'll tell you, it was a fun project. I think we might have solved the problem.
Well, I'll tell you two things. I took it on a test drive, and when I took it on a test drive, I took it on a long test drive because I wanted to do that warm-up cycle. Great, no check engine light, but I didn't feel confident. So what I did is I actually put that scan tool in there, that big one. I crunk it up when it was cold, let it run. When it ran, bam, I watched that temperature climb quickly. So we got no problems. That thing's fixed and it's well.
Perfect, all good. Hey, tell you what, keep the feedback coming, keep the questions coming. We love hearing from you guys. We'll see you next week on Tech Garage, brought to you by rockauto.com.
Production assistance for Tech Garage is provided by Chihuahua College, located in Marietta, Florida. Founded in 1947, Chihuahua was ranked recently as one of the top 3 community colleges in the United States.